Lakshmi Academy. I am Anantha Lakshmi. If you are a new visitor to Anantha Lakshmi Academy, please do subscribe to Anantha Lakshmi Academy so that you will get notified whenever I upload a video. So in the earlier parts or sessions of tangents and secants to a circle, we have already covered the introduction part, exercise 9.1, followed by theorems and statements, and today we are going to start with exercise 9.2, the second exercise, and I have the problems already written on the board. So let's get started with the very first problem. There are 5 bits in it. I have written the 3 bits of it. So the first one says the angle between tangent and radius drawn at point of contact. If this is a tangent, the angle between tangent and radius drawn at a point, this is what is 90 degrees. This is what we have learned in our theorem 9.1. Okay, so the angle between the tangent and radius drawn at a point of contact is nothing but 90 degrees. Now in the second one, from a point Q, the length of tangent to a circle is 24 centimeters. From a point Q, you have drawn a tangent which is 24, and the distance Q from the center is 25. The radius of the circle is, what is the radius? Radius is nothing but distance from the circle to any point on the circle, which is nothing but our point of contact. Okay, this is our center. How do we figure this out? This is nothing but a right angle triangle. The length of the tangent formula, you have it as L is equal to under root of d square minus r square. Either you could do it like this, or this forms a right angle triangle. You can write it as, if you name this as P, OQ square is equal to OP square plus PQ square, wherein you need to figure out OP. No, OP is nothing but OQ square minus PQ square. This is one way of doing it, or if you know the formula, you can directly substitute it like this. Under root of 25 square minus 24 square. 25 square is 625. 24 square is, okay, let me do it here, 16, 9, 8, 4, 6, 7, 576, that is. So 15 minus 6 is 9, 11 minus 7 is 4. So this is going to be 7 centimeters. Alright, that is nothing but the second bit. Okay, now let us look at the third one. If AP and AQ are 2 tangents to a circle with center O, so that angle POQ is given for us. Okay, that is 110 degrees. Then angle PAQ is equal to dash. So if you look at this diagram, angle POQ is 110 degrees, but what is angle OP? This is nothing but the radius. OP is radius, OQ is radius, and here P and Q are point of contacts for the tangents. So this is 90 and this is going to be also 90. That's what we have read in the first bit. Now the angle between the radius and the point of contact of a tangent is 90 degrees. So now that becomes, in short, if we can write it, this becomes a quadrilateral, right? In quadrilateral OQAP, angle O plus angle Q plus angle A plus angle P should be 360 degrees, no? Now angle O is 110 degrees, angle Q is 90 degrees, angle A is, we have to figure out, angle P is also equal to 90 degrees. So this is 360. Now 110 plus 90 is 200, 200 plus 90 is 290. So angle 360 minus 290, this is going to be 0. So 16 minus 9 is 70. So this is going to be 70 degrees. Alright, that is about the first 3 bits of the first problem. Let's look at the 4th and 5th bit. It is given that PA and PB are drawn in such a way that they are enclosing an angle 80 degrees. But from the statement 1, we have learned that this the center lies on a bisector of this. So angle APO becomes 40 degrees, isn't it? So in triangle APO, angle APO plus angle OAP plus angle POA is equal to 180 degrees. What is angle APO? 40 degrees plus angle OAP 90 degrees. Now upon substitution, this goes off. POA is equal to 180 minus 130, which is nothing but 50 degrees. Alright, that is about the fourth bit in problem number 1. Let's look at the next one. So here we have the fifth bit of first problem. In the figure, xy and x dash y dash are two parallel tangents given to a circle with center O, and another tangent AB is drawn with a point of contact C intersecting xy at A and x dash y dash at B. Now they are asking us to figure out angle AOB. This angle we are supposed to figure out. Okay. Let us name the point of contact of xy and x dash y dash as P and Q. Okay. Now let me join OC. Okay, OC. What is OC? Is nothing but the radii. OP, radii. OQ is also radii. So let us write the same. The solution. First we will know what do we know. So we joined OC now. First we know that OC is equal to OP is equal to OQ. These are all nothing but the radii of the circle. And we also know that the lengths of the tangents drawn from external point are equal. Meaning, if I consider A as the external point, AP is equal to AC, isn't it? AP is equal to AC, point number 1. AP is equal to AC. Also, OC is equal to OP. That we already know because that is radius. Now here, OC is equal to OP and AP is equal to AC and OC is also equal to OQ. OC is also equal to OQ. Now here in this picture, all the sides are equal. All the sides are equal. All the sides are equal. Which means this becomes a rhombus. What becomes a rhombus? OCAP becomes a rhombus. Now, look at this. The angle between the radius and the point of contact of a tangent is nothing but 90 degrees. So, angle OPA is equal to angle OCA is equal to 90 degrees. In a rhombus, if one of the angle is 90 degrees, then it is called a square. So, now OACP becomes a square. So, this becomes a square. So, now what happens? When this becomes a square, within a square, the diagonal OA bisects the angle. So, OA bisects angle O. OA bisects angle O. So now this is in a square, all the angles are equal, right? This angle is also 90 degrees. So now angle A, what are we supposed to figure out? AOB, right? Angle AOC is equal to 2 times angle AOB. That is nothing but 90 divided by 2, which is nothing but 45 degrees. Angle AOC is 45 degrees. Likewise, angle COB. Here also, downside also it is forming the square and the diagonal bisects it. So, Angle OCB. Angle OCB is also OCB. Yeah. Is also 90 by 2 is equal to 45 degrees. So now angle AOB is equal to angle AOC plus angle, sorry, this is COB. Okay, angle COB or BOC. So that way it becomes 45 degrees plus 45 degrees. And this becomes angle AOB is nothing but 90 degrees. Alright, so that is about the fifth bit of first problem. Okay, so here we have the second problem of exercise 9.2. Let me read out the problem for you. Two concentric circles. What are concentric circles? If you draw a circle within a circle, then it is called concentric circle. Two concentric circles of radii 5 centimeters and 3 centimeters, okay, are drawn. Find the length of the chord of the larger circle which touches the smaller circle. So let me draw a chord. Chord is nothing but which touches the circle at 2 points, okay, and large circle which touches the small circle. Now I have drawn a circle. Let C1 be the bigger circle, C2 be the smaller circle, and this is at the same center. Concentric circles will have the same center. If I draw a line from O to P, this is the radius of the smaller circle. Likewise, if I draw a line from O to any point on circle C1, that becomes the radius of the bigger circle. Now, what are we supposed to prove? Find the length of the chord of the larger circle which touches the smaller circle. If we assume this as A and B, we are supposed to find A and B. AB, the length. Okay. So let's try figuring that out. So here we have, we need to figure out PA from this triangle. If we could figure out PA from here, AB is nothing but AP plus PB or PA plus PB, right? From there we can write that out. So let C1 and C2 be the concentric circles with radii 5 centimeters and 3 centimeters respectively. When you write respectively, it means that it is in the same order. I said C1 now, C1 5 centimeters, C2 3 centimeters. Alright. Now, in triangle AOB, AO is equal to 5 and the angle between radius and the point of contact is 90 degrees, no? That we know. So OP is equal to 3. Angle OPA is equal to 90 degrees. So from Pythagoras theorem, what can we write? OA square is equal to OP square plus PA square. From here, PA square can be written as OA square minus OP square. PA is under root of OA square minus OP square. PA is equal to under root of 5 square minus 3 square. 25 minus 9 is 16. Isn't it? So this is nothing but 4. PA is equal to 4 centimeters. So if you take this out, if you draw one more point from O to B, this is also 5. The same will happen and PB also ends up as 4 centimeters. Similarly, PB is equal to 4 centimeters. Therefore, AB is equal to PA plus PB is equal to 4 plus 4 and this is 8 centimeters. Alright, that is about problem number 2. Let's look at the next one. So we have the problem number 3 here, wherein prove that the parallelogram circumscribing a circle is A rhombus is what is given. So let us draw a circle and a parallelogram. Okay. Now let me call this as A, B, C, D be the parallelogram, P, Q, R, S be the point of contacts. Okay. Now a circle is circumscribed by a parallelogram. We have to prove that this is a rhombus. Okay. Let us look at the solution. Let me write the given part first. Given A, B, C, D be the parallelogram with the point of contacts A, Q, R, S respectively to the circle with center O. Okay, with center O. What are we supposed to prove? We need to prove that ABCD is a rhombus. Its proof is more like statement number 4, which we have learnt in the earlier video. So let's do the same thing. Here what are we going to use is the length of the two tangents drawn from a external points are equal. We know the length of tangents drawn from an external point are equal. So how are we going to say that? AP is equal to AS, BP is equal to BQ, CR is equal to CQ, DR is equal to DS. 1, 2, 3, 4. How did we do statement 4? The same thing which we are going to do. That is nothing but on addition of 1 plus 2 plus 3 plus 4. 1, 2, 3 and 4. We get AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. AP plus BP is nothing but AB. CR plus DR is nothing but CD. BQ plus CQ is BC and AS plus DS is AD. Okay. This is one and this one and this one. Okay. AD plus BC we wrote. Now, given that this is a parallelogram, as ABCD is a parallelogram, in parallelogram, what happens in a parallelogram? Opposite sides are equal, meaning AB is equal to CD, AB is equal to CD and AD is equal to BC. Now substituting the same, that becomes 2AB is equal to 2BC. 2 gets cancelled. AB is equal to BC. In a parallelogram, when the adjacent sides are equal, here and this side are equal, that becomes a rhombus. In a parallelogram, when adjacent sides are equal, that becomes a rhombus. Therefore, ABCD is a rhombus. Alright. So that is about problem number 3. So that is about this video. I am going to close this video for the first 3 problems itself. In the next video, I will be continuing the next problems of exercise 9.2. Till then, keep watching Anantha Lakshmi Academy, and if you like the content and you are able to understand this, please do like, share and subscribe to Anantha Lakshmi Academy. Also pass this on to your 10th class friends or any of your 10th class relatives. Thank you for watching.